Hello everyone. This is the development section of the how to build a Turing machine that uses a palindrome program. So what this machine does, just a brief recap from last video, is it demonstrates or it replicates a Turing machine that uses the palindrome program. So if I click start, it has a set of tape numbers, and it'll go back and forth between these values to see if the current string is a palindrome or not. So if we speed things up, we can see the current state, and now we can see that the state has been transformed to halt accept, meaning that the current string is a palindrome. If it said halt reject, that means the string is not a palindrome. And that's the string that we're looking to check if it's a palindrome for. So currently the string is hard coded, and this is not extensive program, but just a fun side project that I had a good time doing. So I thought I should share how I built it. So let's get into the code base. So this program is made using JavaScript, and here is the basic uh, structure of the code. So I won't go over everything. I'll go over the most important parts of this program, and I'll start with this. So what this program is built upon is the Pixi.js library. Pixi.js is a rendering library that is used to render. It's actually a HTML creation engine, and it's useful for making game type of JavaScript applications on HTML web pages. So it's very useful in that sense. So moving on, so we're creating an app, and this is going to be our stage for the game. Over here we have the Palindrome program state rules. So these are the state rules that govern the program. So a state rule is basically how a pointer decides when to go to the next square or what to do in a current square. So for example, you can see the pointer is at this position. Now if I click resume, it goes the opposite direction. So now why did it choose to go the opposite direction and not this in the right hand direction? It's because we had a state rule that said if you come to a white space, then go to the opposite direction. So this is what this array, this 2D array of state rules is doing. It's guiding this pointer so that it can look for whether or not the string is a palindrome or not. So you can see that the way that this array is formatted is this first element represents the current state, second one represents current symbol, new symbol is represented by third, direction is represented by fourth, new state is fifth. So the current state is this right here. That's the current state of the program. Current symbol is what the program is currently pointing towards. So right now the current symbol is 1 because the pointer is pointing towards 1. New symbol is the new symbol that is going to take the place of 1. Sometimes the new symbol might just be another 1. So the new symbol will replace 1 with 1. So it may seem as if no change took place, but there was a switching. The direction is left or right, or any. So R means right, left is represented by L, and the star is goes for any direction. Any direction meaning if the pointer is going left, then just go left. Oh, sorry. If it's star, then it means it's the accept state. So that means the game is over. You can see that in the accept and the reject states, the direction is null. So this is actually null. It means you don't have to move the pointer because the game's already over. And then you have the new state. So the new state is once this, let's say the state rule or the direction for this current state is left. So it goes to the 0 position or this position, and the current state will take the place of new state. So this new state is going to be assigned to the current state. So that's the current state going forwards. So you can get the general sense of how this program works. Um, for it to move like this, you can see that the current state is changing now. It needs these rules. These rules are what governs that behavior. Without those rules, this program wouldn't work. So it goes, and when you see these dash signs, it means it's taken up, so that um, the current square does not contain any letters, so or numbers. So there can be either 0 or 1, and it cannot take any of those. Once you see a smiley face here, that means it's a halt accept state. If you see a uh, halt reject, it means this string is not a palindrome. So moving forward, we have the comparison values. So comparison values are useful in comparing what this current string is pointing to and what to replace it with. Uh, this will make better sense as we move forward. So in Pixi text, we're just rendering some text sprites. Here we have current state, we have not available, and then we're creating some buttons. So you have the start button, restart button, stop button, resume button, and you have the event listener functions for these buttons. So you can see that on resume, on mouse down, you trigger this function when the mouse is down on the resume button. The resume button is this right here. So when I click it, that function will be executed. And what it's doing is it's resuming the interval function or the interval component that pauses or starts the game. So next we go to restart palindrome. So this is also an event listener function. We have the reset game function. So this function is responsible for resetting the game. So a game reset would be like this. So once it's done, you can have the option to restart, and that function resets everything to normal. So you have the toggle start button visible, game speed, restart button. So that's toggling this function right here. So when we pause, you see the select game speed slider that can be used to adjust the game speed. So now if I put it to a moderate speed, it goes slower. So that's being handled by these functions right here. Render tape pointer, pretty self-explanatory. So it's rendering this pointer. Set up the palindrome tape. Okay, so here we have the tape being set up. So you can see that 10001001, that value is what is being shown when you first start the game. So when you first start the game, 10011001, this is the default values that are being rendered, and that's because of this function right here. So it's hard coded for now, and I think that serves this side project well. But this is how it's being made. So each square is being represented by a variable, and that list of variables is inserted to this array of tape squares. Then we iterate through each array and we space it out evenly. So you can see the x and y coordinates of these numbers are spaced out evenly. So that's what's being done here. We're updating the text, fill it with black, add child. So add these tape uh, numbers to the stage and then moving forward. So render state text. So you can see the current state being changed to 1i. So that's being done by, so that text is being rendered by this function right here. Next we have render tape with Pixi. So render tape with Pixi. This is a repeat of what we have here. So this might be some redundant code. I should do some fine tuning here and remove some redundant code. But moving forward, you have move tape logic. So move tape logic is primarily responsible for moving the tape And before we get into that, let's get into start tape. So start tape is what starts the game. When we click start, that's what's being called. It calls this interval timer. And this interval timer is a custom class that I created that basically allows us to pause and resume the game anytime we want, clear the interval, start the interval, run the interval. And you can see that this is using the set timeout method that it comes with vanilla JavaScript. But this is just some add-ons that are added on to this set timeout method in order to give it additional functionalities, such as the start, run, pause, and resume. So set timeout only has start and stop, but now we have a resume and pause because we created this new class called interval timer. So if we go back to start tape, what we're saying is interval timer should execute this function based on the current game speed. Move tape logic is this function right here. So this is the main controller of the program. What it does is it gets the input. The input is the current number that the tape pointer is pointing to. It takes that input and then gets the move tape direction. So process input is checking the current tape pointer and doing some logic, doing some calculations to get what the direction should be. So what we're doing here is if we found a match meaning, hold on, over here, you can see that there's a list of state rules. What this function is doing is it's going through all these state rules and seeing that if the current state of the program, for example, if current state is 1i, current symbol is 0. So if we go to current state 1i symbol 0, so this means any symbol, by the way. So this function, this state rule would apply in this case. What this function does is it recognizes this state rule, and then if we set found match to true, then we return the third index of this array. So 0, 1, 2, 3. It returns right. So we need to go right. So now if I resume the game, it goes right because that state rule was implemented. So that's what we're doing. If we're not able to find any state rule for the current state of the game, then we just say halt reject, and the game immediately comes to a halt. So you can see process input here, right, left, and it's moving the tape pointer. If it's right, add 25. If it's left, minus 25. Current head index represents the head of the tape pointer that it's currently pointing to. So that's just a programmatic representation of what the GUI is doing. So, and if you say halt reject, then we clear the interval and we stop the interval, and then we toggle the restart button, show the restart button, and that's it. The game has ended. So now we covered process. So this is just some complex logic that uh, goes through that state rules array and looks for a possible state rule that it can use to move that tape pointer. So this is also a helper function that it's using over here. So compare tape values. For what this is currently doing is the current head value is this. So 1. Current state symbol is probably, it could be anything. Current symbol could be 0, 1, dash 1, anything. So it just compares this to that. And it uses this comparison values object to compare it. So let's say current state, current head value is 1, 1, and now we see current value, current state symbol is also 1. So then this would apply. Since we found this, we can return true. So that's how this object and this function are comparing the values. Set new symbol on tape, so that's self-explanatory. So that new symbol, which is in the uh, third position here, is taking the place of the old symbol. Next, we have the class that we defined, interval timer, custom class, that's built upon set timeout method. Next, we have the slider logic. So if you see this logic right here, the game moves based on what the slider value is. So we can adjust the speed of the game, and that's being done by this code. So handle, it's using Pixi graphics. So you have the click events or the pointer events for this slider. So if we drag it up or down, this on drag start method will be triggered. And what it's doing is it's over here, it's handling the game speed. So it's using some mathematical calculations or equations to adjust the game speed so that if you adjust it towards this side, it goes slower. If you adjust it towards this side, it goes a lot faster. So that's being taken care of by the on drag function. The on drag function is right here, and it's being called by this pointer move event listener. So listen to pointer move, stop dragging once the handle is released, and now we have the title over here. Select game speed. So this is just the interface, graphic interface text at the pause, resume, start. So pause, resume. You can't see start because the game's already started. And then you have the restart. So restart shows up now. And that's pretty much it. So it's a relatively simple game that is mostly hard coded, but it gets the job done in terms of representing a Turing machine. So uh, this, although it is a hypothetical machine, it can be represented using some JavaScript, HTML, and CSS. So for the sake of this program, it only does the palindrome program, but this Turing machine uh, implementation can implement any algorithm that it chooses. It's just that for this program, it only uses the palindrome program. That's what it does here. So I hope that made it clear what this program is doing. I'll include the GitHub link for this program so that you can clone the code or make additions or study it or whatever you need in the description of this video. Thanks again for watching this video. I hope you found it useful, and if you did, feel free to like the video or subscribe to the channel. Thanks again, and I'll see you in the next video.